speaker is Mr. Jacob Niemeier with Stanta Consulting Services, Inc. He'll be presenting on the Water Master Plan in the Present is the Future for Smaller Cities, case study for town of Addison. As a professional engineer working for Stantec, Mr. Niemeier has over 5 years of experience in public and private sector. His experience includes design, modeling, cost estimation, professional presentations, client project coordination, and varying levels of project management. More specifically, he has performed erosion and water runoff computer modeling and simulation analysis of lid and erosion control best management practices, sustainability analysis for using InVision, utility coordination, opinion of public construction cost estimating, flood plan delineation, stormwater, hydrologic and hydraulic modeling, water distribution system modeling, small diameter water and wastewater utility design, wastewater lift station design, large diameter water and wastewater pipeline design, public works construction inspection, and construction administration. Mr. Niemeier graduated with his bachelor's degree from Purdue University in 2012, and during his free time, Jacob likes to fish and play basketball. Please help me in welcoming Mr. Jacob Niemeier.
So because I'm so tall, I'm going to take the speaker off of the mic stand. Otherwise, I'll end up with back problems, and you don't want that. I could raise it, but I also like to walk around. I'm a very mobile individual. So thank you so much for having me. I'm excited to be here. I wanted to first state something that Farwa pointed out earlier when she said, when I graduated in 2012, she pointed out that makes me really young. So hopefully my millennial speak will not go over y'all's heads. But thank you. I'm really happy to be here, and I'm really excited to share this presentation with y'all. I actually presented this at Texas Water last year in April in Austin. So it's a presentation that I'm very familiar with. Unfortunately, my counterpart that presented with me then, Jason Schroyer, Assistant Director of Public Infrastructure for the town of Addison, couldn't join me today. So I'm on my own. So hopefully I do a little bit better than expected. So thank you. First off, I'm going to grab this little thing that can control the PowerPoint. Maybe. Just a little introduction. Just the location. We're in Addison, in case y'all were unaware of that. So this is where our project is. We did the Town of Addison's Water Master Plan a few years back. We're also going to cover today a system overview of Town of Addison's infrastructure and water system, the intentions of our water master planning and water modeling project for them, our approach, scope, results, final deliverables, conclusions, and future implications that this has for Town of Addison. In fact, some of those implications are already underway right now, which I'll briefly touch on at the very end. So there's Addison, upper left corner, green area there. Just a little overview of Addison's water system. They have approximately 6 DWU, not approximately, exactly 6 DWU interconnects. They have 2 primary connections and 4 emergency connections to DW system. They are wholesale customer from DW. They do not treat their own water, so they buy entirely from DW, and in rare circumstances they can also take water from Carrollton and Farmers Branch. They have 3 interconnects with Carrollton and one emergency connect with Farmers Branch. They have 2 pump stations, 2 ground storage tanks, 2 elevated storage tanks. And of course, pipes, valves, hydrants, we all know that. They also have a pretty substantial SCADA system, pretty state-of-the-art. So that was helpful in our water modeling and data collection stage. So the state of the town, the reason why we came on board and Addison was seeking help with their water modeling and master planning for their future growth and development was, simply put, the aging infrastructure, poor record keeping. Record drawing as-built were very, very sketchy, not very well managed, and frankly, a lot of what they had before in their GIS mapping system was pretty unreliable because it was indicating some water lines that were actually stormwater lines and some water lines that were actually wastewater lines. And so they had some inaccuracies there as well. Also interesting, should point out, is currently Addison is mostly built out. However, they are doing a lot of redevelopment. I don't know if you all know the Beltline Midway. It's actually just up here, just north of here. Beltline and Midway area, they're doing some substantial redevelopment there near the Sam's Club. They also have known problem areas within their system where they have leaks and pressure issues, and they just wanted simply a solid CIP foundation from which they could build future master planning and development decision making off of. Man, this button is not working. I have to click it like 3 times. There it goes. I promise this is not because I'm a millennial. I actually should know how to use this. Intentions. So what are the intentions of this project that we did for the town of Addison? Well, we started it, I should mention this back up. We started it back in 2015, and we finished it within about a year and a half, I should say, from project inception to completion of our water modeling and master planning. And so the intentions ultimately were to understand their water distribution system assets, improve their operational efficiencies, ultimately develop that water master plan that I keep mentioning, and come up with a list of CIP capital improvement projects that could be done to effectively meet their current needs, future development, and aging infrastructure. So let's try the button. Maybe I have to click it harder. Oh, that's what it was. I have to click it a little bit harder. Our approach. So our approach was we needed to go above and beyond because, I mean, frankly, let's be honest. The reason why my presentation this afternoon is called Water Master Planning in the Present is the Future for Smaller Cities is because, frankly, right now it's never been easier in today's modern day and age to do water modeling and master planning at a low cost. Before, it used to be fairly cost and time intensive that some of these smaller municipalities wouldn't be able to afford that, or they didn't see any ultimate benefit in that. But now with the way we have softwares, modeling programs like WaterCAD, which is what we use for our project, there's also other ones out there as well. It's never been easier to dive into a project for a small community and do something at a low cost that is extremely beneficial to them. So us recognizing that at Stantec, formerly Bury, I should mention too. We were Bury when we got hired on as this contract, and we've now since been acquired. So Bury now Stantec. When we got hired on to do this, we recognized we needed to go above and beyond. We needed to prove to Addison that this was worth their investment. And we needed to do this in a way that was just beyond even just engineering and technical aspects. And we believe that we did that in a number of ways. Project status reports are something that I want to highlight that we've found have been very useful for our coordination with our clients, and Addison very much enjoyed those, where we provide an update on previous week's activities planned for next 2 weeks, 6 weeks, and then Town of Addison action items. We do this on a bi-weekly basis, which is cool because Addison felt like they were engaged from the very beginning. We also believe that communication is key. We can't just get a project, win a contract, and then go to work and never talk to our client, especially on a project where we're engaging them and having to work closely with their operations and maintenance staff to get data from their SCADA system for the water modeling and other aspects that are operating their system. And then, of course, accuracy is critical. So, speaking of accuracy, scope. we had to clearly define our scope so that we could be accurate in what we deliver to them. So just a brief overview, our scope, we had GIS map development, water model development, water model calibration and validation, and hydraulic analyses. That picture right there, this doesn't work. There it is. That picture right there is of Celestial Pump Station. They have 5 two-stage vertical turbine booster pumps there. That's one of their interconnect locations with DWU. And so that's also where their SCADA system is located. So that's where their computers are. So we got to spend a lot of time over there. That was fun. GIS map development. Of course, any foundational water model, as you all may know, or any modeling period is only as good as the map that you're going off of. It's only as good as the base building block, so to speak, that you're using to evaluate the system. So we believe that, of course, this GIS map development process, as you can see here, we took what was already existing in Town of Addison's GIS system. We did a full record drawing review, cleaned it up, found, as I mentioned, stormwater lines that were showing up in their water system GIS map that were not actually water lines, they were storm. Same with wastewater. We cleaned all, we connected everything in very nicely, and we've developed this really pretty map here on the right. And then, of course, we also embedded all of the data into their shape files. We did pipes, as you can see here, with all of the geofile reference. So that's referencing to the record drawings. So now they can go back and find those record drawings much easier. We organize them. The date that was updated, the date that it was installed, just all that information is in there. We did the same thing for hydrants, valves. This was the first step in our process, of course. Storage tanks. And then we got into the water modeling. This is where the fun stuff is, actually. The map development is important, but the water modeling is where we get to flex our engineering minds and our muscles, have a little bit of fun, and come up with some cool ideas. I actually really enjoyed doing this because it was kind of my first exposure to a large-scale type water modeling process. Before, I had done a lot smaller stuff for private development projects, small additions to larger existing systems. This was full system modeling. It's really cool. Got to finagle with a lot of the components. We used the model builder tool in WaterGEM's VAI, or also known as WaterCAD. It's just their higher pipe version, to add in our pipes, our junctions. All that data was built into our GIS system. Then we, of course, skeletonized, and then we did hard input all of our tanks and our pump stations. I also want to point out some cool pictures here, too. This one in the upper right over here is a butterfly valve vault covers on the back side of that Celestial pump station. They have a pretty new system over there, but they are actually doing some upgrades based on some modeling operations recommendations that we've made from this modern master plan. So it's pretty cool to see what it looks like now, and then hopefully we'll get to see what it looks like in the future. And then this is a Surveyor elevated storage tank, which is their newest elevated storage tank in the town, built back in 2007. We'll go to the next slide. Oh, too far. We developed water system demands. This was really cool too. Addison has a very unique system. They provided us all their meter data for the system. We took all of this data and we basically did a meter by meter analysis on what type of development that meter was associated with, and then we created a demand for that type of development based on the meter data that Addison gave us, the historical data that they had given us. And then we created projections from once we provided or come up with what the theoretical demand was for that type of development for the town of Addison specifically. We then projected that to the future for future development demands. Also, I should also mention we did a comparison against standard industry standard demands as well. DW has some demands that they recommend, Fort Worth, so on and so forth, some of the bigger municipalities. But it was cool. We tailor-made our demands to the town of Addison specifically based on record data that they provided us. And then, of course, we did our development. We inputted existing demands. We developed our peaking factors, which was also a unique thing for specific to town of Addison that we did. We of course did compare against industry standards as well. AWWA was one of the standards that we went off for our peaking factors. But I would also mention that Addison is very unique, which I think is on the next slide. Oh gosh, Millennial Problems right here. Wow. I think I was having better luck pointing it this way. Let me try that. Maybe I point it off my head. My head will. I know, I was pointing it over there. Okay. All right. No, that's one. That's the one. Stop. I'm sweating. That probably is just because I'm a little nervous up here. No, actually, so Addison, I wanted to say, is really unique in their peak demand curves. This is a diurnal curve for the town of Addison. As you can see, at about, I think, 3 a.m. in the morning, they have a peak, and then about 10:30 p.m., they have another peak. That's very unique. Addison's residential population is only about 10 to 15,000, but during the day, their daytime population can spike to well over 100,000 because they're extremely built out with commercial and retail and restaurants, as you all know. We're sitting in one of those type of facilities right here. So it's kind of unique in that their irrigation that they do for all these properties occurs about 2 or 3 in the morning, so that's why we see a peak there. And then we kind of pin the 10:30, 10 p.m. time period to bars, restaurants are closing, everybody's leaving. Dishes are getting washed, people are flushing toilets, people are maybe arriving home and, starting to use their facilities. So it's kind of a unique system that doesn't normally function, that you don't normally see on a normal functional level in other locations. So, and then we developed our water model as we continue out here. We then looked at future demand determination areas. We did our 5-year master build out and other undeveloped tracts map, which is the one you can see on the right. So everything in blue is in their master build out plan. Everything in red is their 5-year build out plan. Actually, that red one right up there, kind of right in the middle of the screen, see if I can point right here, is that development at the Sam's Club on Beltline and Midway. There's a lot of data on these slides, so I'm going to try to, if you guys have questions at the end, definitely, come back to them. But I want to kind of try to cover as much as possible here. There we go. Oh, there we go. I was already on the right slide. Oh, look at that. So then we calibrated and validated. So I should also mention the calibration and validation process was a very fun iterative process that we went through with the town of Addison. We worked closely with their operations and maintenance staff. I spent a lot of time up at their Celestial Pump Station, which I showed you a couple pictures of, hanging out with their operations and maintenance guys, chumming it up, so to speak, and building good relationships with them. It was a lot of fun just going out in the field, seeing how they run their system, and then also working closely as we guided them through the process of running our fire flow analyses to collect the data that we then used to calibrate our model that we had developed to the real-world conditions. The hydraulic grade line recommended variance for these systems is plus or minus 5 to 10 feet. In terms of if you can get within that range, then you can say your model's fairly accurate. It took us a while to get there. We had to manipulate Hayes and Williams C values in our model. We had to change pipe materials a little bit. We had to adjust some valves that were maybe closed or not closed based on field conditions that needed to be shown properly in the model that we discovered during our fire flow analyses. But all in all, it was a very iterative process that was quite enjoyable to work through. Hydraulic analysis. These are the analyses that we look at. Analyses. It's plural, not singular. I'm taking Spanish, by the way. And so now, like, sometimes I start speaking in plural and singular. So I apologize that I'm using those words for those that don't speak Spanish. So steady state analysis. We did phase 1 was steady state. We looked at the 12 different demand conditions, as you can see up there. And then we had a phase 2 where we an extended period simulation and water age analysis, which actually came on the back end of the project, was not in the original contract. Then town of Addison, about midway through the project, said, we want you to do an EPS analysis and water age analysis based on some recommendations that we had provided them during the project. And that actually, frankly, probably wouldn't have happened if we hadn't walked with them as close as we had through the project in terms of giving them these updated project status reports, spending ample amount of time with their staff and working closely with them. They realized that there was benefit in doing a more in-depth EPS type of analysis. Then we looked at our hydraulic design criteria. These were based off of AWWA standards. We ran our models, evaluated based on the table as you can see there, and then we provided capital improvement projects that would meet those demand conditions. That should not have transitioned. There we go. So whoever's running the mouse for me, thank you so much. I appreciate that, because this thing is frustrating. So then we did a CIP for the systems from these from the demand conditions, and then comparing these hydraulic design criteria to determine areas that were not meeting the priorities of the system, hydraulically speaking. And then we began to do some additional analyses from that as well. Did operational controls evaluation, storage and pumping evaluations, water age and quality analyses, and then we also looked at some emergency management evaluations as well. Also, in the bottom right left corner there, if we could go back to the next slide, bottom left corner there is the surveyor pump station, which right now Addison's in the process of remodeling and upgrading that. So it's really cool because we got to do our whole water modeling analysis. Now Addison's going to upgrade this system so that they can run the whole system on this one pump station if they ever had a situation where one Celestial pump station went down. Surveyor is just up the road from here actually. And so this is an older system that was built back in the early 80s, and it's just been in need of upgrade for a while. So it's cool that we can tell them that you can run your whole system off of Celestial, and we have operational guidance and recommendations on how they can do that, even with Surveyor down. So that's kind of neat that that came out of that. Go to the next one. Thank you, Philip. You're man among boys right now. CIP recommendations. We came up with a list of 22 steady state analyses. CIP recommendations, as I mentioned, that was our first phase of analyses. And then we came up with an additional 2 during our extended period simulation. A lot of those were overlapped, so during our extended period simulation, it's meaning, in case it's not clear for y'all that are, I'm maybe not speaking a language that you all have heard before, steady state analyses, we're looking at just a snapshot in time. And then extended period simulations, we're looking at the system over time, i.e. the diurnal curve that I showed you earlier. So the snapshot in time is usually worst case conditions. So if it doesn't function during a snapshot in time, then during a worst case condition in the system, then it's also not going to function. Extended period simulations, it's going to pick up on things that are maybe not worst case in time, but they are more of a chronic type issue in the system that allows us to kind of get more depth on what CIP improvements would be needed. And so that's where those EPS determined ones came from. Now, I should also mention the EPS process. There was also overlap. So a lot of the CIP recommendations that came out of our CIP for the steady state also were in the EPS as well. But it was cool to see the overlap and actually get confirmation that what we did during our steady state analysis was actually accurate because the EPS model verified that. So then we also came up with a couple related to the water age analysis that we did, i.e. we're looking at areas where the chlorine residual levels may be low and thus resulting in potentially contaminated water that may affect the residents and customers of that water. Go to the next slide. Thanks, Philip. Water age. I'll just point this out here on the left. It's maybe hard to see, but there's here. The one on the left shows all of their sampling locations that they have for EPA sampling within the town. And then the one on the right shows all those sampling locations overlaid with areas that we determined were not meeting water age requirements based on AWWA standards. And then we went in and provided capital improvement project recommendations, i.e. adding pipe or changing the model a little bit to fix those areas that weren't meeting those system requirements. And we came up with a map and final deliverable for that. So then, some of the additional results, I won't cover this, but just touch on it. We did operational controls evaluation results, emergency management evaluation results, which were very interesting aspects that Addison really appreciated, especially the emergency management component, because we got to look at, as I mentioned before at the beginning of the presentation, they have 3 emergency interconnects with Carrollton, 1 with Farmers Branch, and 4 with DWU, and they didn't really quite know before this process, before we did our water modeling and master planning for them, how those emergency interconnections would work if they had to use them. And so we were able to provide some insight into that during our analyses. So risk-based analyses that we did. So this is where it gets really technical and also subjective at the same time. So we took that list of CIP recommendations that we came up with, which ended up being about 26, right, total, and we needed to evaluate them and prioritize them so that Addison can have an actionable list moving forward. And so from those CIP recommendations, we recognize that there are some things that are more important than others. And Addison specifically told us that in the end analysis, cost is not that important to them. What's more important is the safety of their citizens and the maintenance of their system that they may have to be worried about if an emergency were to happen. And so from that, we've developed a consequence of failures criteria and a likelihood of failures criteria, water environmental quality issues, hydrants are out of service or hydraulically hindered. Those are big issues. They get a weight of 10. Meters are out of service. That's 8. You can see the list up there. Location of failure. That's a 2 because almost every location is going to be fairly devastating potentially, but some are less than others, of course. But the weighting is lower. These weightings, we worked back and forth with Addison to come up with the best weightings for evaluating their CIP. And then, of course, we had our sub-criteria for these as well. Just an example, on the likelihood of failure, pipe material. So, first, pipe material, my phone's beeping at me, that's my alarm, which means I have a little bit of time because I put a fluff in there. think I have a few more minutes, so which is good because I'm almost done here. And we came up with capital pipe materials, and we gave them sub-criteria. So we'll move on to the next slide, Philip. And so I mentioned COF, which is consequence of failure, or LOF, likelihood of failure. They're two different items that we evaluated their CIP off of. We then took our sub-criteria rating, as I hinted at, times our criteria weighting to get that value. And then we get our risk factor, which equals COF times LOF. And then we plotted these on a curve or a chart and showed which ones are the worst potentials in their system, CIP. And then we prioritized them based on our risk. So if we can go to the next slide, Philip. And then, so the list of 26 CIP improvements that we provided are then now prioritized based on the risk factor, as you can see in the fourth column, right there. And then we also, of course, Addison does care about cost, but they didn't want cost to be a decision maker in prioritizing. So then we also then went on and provided cost estimates for each of those CIP improvements that we had recommended. So we'll move on to the next slide. This is a really fun map. This is my favorite map, actually, because you get to see areas in their system that need improvement. And you get to see, based on what demand conditions that is showing it needs improvement for. For instance, everything that has a blue arrow or is a dark blue line on the legend here, you can see, is something that, based on our recommendations, needed to occur immediately. Based on current demand conditions, they were already having hydraulic issues, and they confirmed this with many of their field efforts and issues that they're having issues with immediately. So these are stuff that's highest priority. And the white here, 2020 improvements, we're looking, that's at our 5-year build-out demands. And they're also priority, but not as high a priority as the immediate demand situations. So our final deliverables, I've covered a lot of material, I understand. So I hope you have some questions for me when I'm done, because I really like questions, because I sometimes can miss stuff during my presentation that you guys may see. Our final deliverables were wall maps, map books for their field guys, which show all their GIS systems and everything that they could go then take out in the field and mark up and use on a day-to-day basis. We also provided record drawings, electronic directory, which they had little to know of before, and that was much more organized once we were done. We provided comprehensive GIS map with detailed attributes, comprehensive water model, risk-based analyses, priority matrix for all the planning that we had done, 154-page water master plan report, which, as an engineer writing a technical engineering report, 154 pages is fairly substantial, and that was a lot of time and effort went into that. And then we also did a specific TM for how they can better manage their operations and maintenance. And then finally, if we go to the next slide, final conclusions. I mean, it's a pretty big deal that we started this July 2014. I should mention we finished in February 2016. Original budgeted fee for the project was about $387,000. We had about $80,000 in change orders, but $45,000 of those change orders were associated with Addison giving us additional scope that they wanted us to do. That was not a result of the project not meeting what they originally wanted, but they wanted more. And so that was cool, really cool. And then our approach, we believe the reason why our project was a success because we were different in what matters to the client that we were serving, which is Addison. They wanted somebody that was walking closely with them, that cared about their system, that wanted what was best for the future of the town of Addison, and were willing to communicate and do what it took to make that a success. So, final slide here before questions are available. Future implications. Future implications of for Addison, but also for any system of the size of the town of Addison, or even larger systems that don't have a water master plan or water model. The future implications are it gives them a comprehensive overview of their system that a lot of times they just don't have. A lot of times they're in fight or flight mode. They're constantly reacting to issues in their system, failure in a system, a leak here, whatever it may be. It also gives them that increase in confidence and effective of operations and maintenance, asset management, planning, accommodating all their future growth, maintaining customer service, which specifically to the town of Addison was extremely important. Town of Addison has a very high reputation of having great customer. I probably don't need it anyways. So is it back? Oh, it's back. Well, I like sound more like God. God, don't smite me, please. So I will add finally that in the long term, Addison believes that this is going to save them money, and we believe that any system that doesn't So without further ado, are there any questions? Any technical questions? Questions why I'm so handsome?
Other than being at the station,
Yeah.
to verify the links in the system. When you
Yes.
said that some of the pipes were sewer or so on, how do you
Great
verify?
question, and I did. Yeah, so he asked how much field work was done to verify the links of the pipes and other aspects.
Hear me, but I don't have a lot of voice as Jacob, but we'd like to thank him for coming to present to us with an ASC portfolio, and also thank him for being patient with our technical difficulties today. So thank you so much.